want to talk about API design, and I want to talk about how it fits into the broader context of a whole and complete system. One of the core tenets of API design is this idea of hypertext as the engine of application state, and it's basically one of the guiding principles of REST, developed by I think Roy Fielding, pretty sure his name was. And this is basically the idea that you shouldn't have to, or your client shouldn't have to have any knowledge to use the API. You should just be able to call the endpoint. The endpoint should be idempotent, however you want to pronounce it. Basically, you can repeatedly call it and it's going to do the same thing. It's going to return back the same thing. But that's the response it gets back. Let's say we sent a GET request to get the weather forecast. In that response back, we would have the data, but then we would also have a category for links. And the links would be anything that we could make any pull requests. We can, change the scope of our weather forecast. We can delete a weather forecast from our phone. We can update a weather forecast. We can insert new one. It'll give you everything that you need in order to properly utilize the data that returned back without having to have any knowledge of the functional system. And so this way of creating this kind of separation between data and links as part of your JSON response is a way to adhere to this core principle of hypertext being the engine of application state. Because the whole idea behind REST APIs or RESTful APIs is that they're quote unquote stateless as compared to something like SOAP. And your request back or your response back should be indicative of everything that you could potentially do with the data that you return back. And this is not something that is going to be given to you out of the box, right? If you let's say make a template API from .NET's, weather forecast template, it's not going to be in this format. It's going to return back, just the weather forecast data because that's just like standard practice. So it takes a little bit of work in order to better adhere to some of the principles. And I'm not going to go into all the constraints of REST, but I'm just going to talk about this one specifically. It takes a bit of work, and it may seem a little bit unnecessary up front, but I think that if you work to put it into practice, which we are going to do on this channel, I'll make a video covering how to do it in .NET with C#. But I think if you take a little bit of that time up front to actually craft it in and make that the design pattern of your system, I think it's going to pay off because the more you adhere to these foundational principles that have been just kind of researched and put out there, I think the better people are going to be able to come in and recognize and pick up on the patterns. It's kind of, in part, it's an adherence to protocol, but in the second part, it's also, just maintaining readability of the system and making sure that when somebody comes into it, they can detect or they can, have familiarity because we're following set principles. And so all it really would take on our in our context on this channel would be to make a new object with, could be a field called data, could be a field called whatever you want the field to be, but then there could be an array of links that we just pass down. We build those. We put the HTTP verb, we put the action link, and we put, whatever other description we may want associated with it. But we put that in there and we bundle that, repackage that, or compose the object like that, and we return that with the data, or with the response. So whenever we call our endpoints, we know that, okay, all we have to do is just say result.data, dot whatever it is. And or if we want to get, okay, we have to make a request to get details, we could just say, okay, we could just do result.links. Whatever weather forecast update, whatever it is. I'm just making an example, but that kind of pattern drives, I think it drives better development because it makes everyone adhere to the same set of standards. It's not ambiguous. It's all kind of clear because it's already been defined by this this third party, this overarching principle behind REST. And I also think that it makes you think about API design in general, because I feel like the default for API design is just simply to return back your JSON object, whatever it may be. Like on the channel, we return back an engine detail object. We return back. I think I'm trying to think what else we return back. Like some kind of object from not the engine detail. What was the other one? The user engine table that we had for an engine that corresponded to a specific user. But those were just, regular plain old classes, right? POCO objects. And we returned that in serialized JSON, right? It was just a JSON object through a response. And that's okay. And especially if you're just navigating between system to system responses, like that's fine. But there may be a case where we wanted to, send a request in order to get details based off the user engine. Then if we have that link available to us, it makes it a little bit easier because we don't have to know anything about the system to make that call. All we have to know is, okay, we just use this field and send it up and get the response back. And so it'll make it simpler on our end, but it'll again drive us to better uniformity in our design. And API design is not easy. It's challenging because on one hand, you look at APIs as something that's always subject to change, right? Especially upon initial development, because we're still defining the interfaces, we're still working, who are the consumers of these endpoints, so what does the data need to be structured like? And a lot of times that's very it's variable, right? It has to change and update over time as we further get requirements and we further flesh out, okay, like what does our engine actually have to do? Like, what does our front end for our engine simulator need? What data does it need? What is the Rust microservice going to consume from our two-stroke engine backend? Those are the kind of questions that are going to come out, right? And our API response is probably going to be subject to change early on, especially if we don't do a good job defining that interface up front, or that that contract for what the API response is going to look like. And so, one hand, it's tempting to just always put the API response in this category of like variability, but I think that makes it hard down the road, because once you start messing with that interface, you have to then reflect that on whatever consumers generally. If you're using explicit types, now if it's always going to be dynamic, then you don't have that much of a problem. But generally, the assumption, especially when working with .NET systems, is that you'll probably have to update the variable or mapping object, to get that new piece of data. So I think for API design, it's very important that you make the interface up front and try to flesh that out as much as you possibly can before you go too far in development. Because the more code you've written based off that interface means the more code you're going to have to touch and modify and get reviewed if you add to that interface or subtract from the interface. We all know this very well, right? We all know we have to do a lot of code changes whenever we start messing with API responses. And so it's very important to define that interface, but I think it's also equally important from a testing perspective, because once you have your unit tests in place around whatever type it may be, when you start messing with that, you're going to have to go and mess with the tests. And that kind of diminishes the credibility of tests, because you have to update them and they're going to fail. And then you have to show, okay, here's why we did update them. It just kind of creates this string of work that could have been partially avoided. I say partially because I don't think it could be all the way avoided. Partially avoided had we spent a little bit more upfront time better defining out what our interface or class for the response needed to be. And while it's unavoidable a little bit that you're going to have to modify that based on unforeseen circumstances, I think it warrants a little bit more upfront attention. And another thing that I feel like it's important to get right early on for API design is understanding what the performance implications of the endpoint are going to be. Like, what is the expected throughput going to be? Is it acceptable to have a return type of a certain size, Or do we have to truncate it a little bit and modify how the endpoint is working? Do we have to postpone the processing from to a later time and return back a lighter weight object only containing partial engine data? Because if I tried to return 4,000 records of revolutions of the cylinder from my engine in one go, thousands of times a second, that's probably not going to fly. That's too much data that I'm trying to return back from a single endpoint. So I either have to truncate that and return back some kind of additional detail call that has to be made and return only the bare necessity of data that needs to be sent to that user at that time, or I have to send a message off somewhere either, and then let's say I can send it to my queue. A consumer can then get that message and say, okay, we need to get this, this, and this data, and then post that back at a little bit later time, or post it back to a table or some kind of caching layer, and then it will be retrieved by our API or by some endpoint and then return back again. So there's a number of different things we'll have to do. And that becomes tricky too to do that, because not only do you have to coordinate, okay, who was the first in that needs to be processed, but you have to make sure your timestamps are in order, and you have to make sure your IDs always relate so you can match the data back up. So there'll be a little logic to get those things squared away. But I think, those are some of the things that are going to be driven a lot by what your expected throughput's going to be, right? If you're only sending 1,000 requests every hour, I mean, you don't have to worry about it probably, right? But obviously, if you're sending 1,000,000 requests every minute, like we try to do in our two-stroke engine project, then you're going to run out of resources pretty quick. And we saw what happened. And if you're interested to see what that looks like in the context of a REST API, I did performance benchmarking with a REST API versus using SignalR to make requests. And that's another thing you're going to have to see. Is REST even the right option for us depending on our use case? It might be it might actually be the case that we want to just send a one-way piece of communication via WebSockets with SignalR on our .NET app, and then receive a response back at a later time. So it really is dependent on data. Data drives so much of the decision making that we have to do inside of our app, and it's a very, very important thing, because if we have data that we have to group together, like our engine data, our user engine table, we have to join those. And let's say, for example, we saved a log of like that engine running for 5 minutes. So we have thousands and thousands of records, and we have to join all this data. We have to do really complex stuff, and we're trying to do maybe some kind of filtering through SQL. All that to say is we have to do a complex join, and it ends up taking a little bit longer than we expect. The latency is a little bit higher than what we'd like, and sometimes it's unavoidable. And we try to do indexing, we try to normalize our data as best as we can, but we can't seem to get the latency down just due to the nature of data. And so you're going to have to mess with that as well, because if our response from whatever data source it is, if it's just simply taking too long to be appropriate for a fast REST API or a fast endpoint, then we have to look at alternatives. Can we get away with adding some kind of caching layer somewhere? Can we scale the database? Is the database the correct choice of database? Is there a better technology to use? There's so many different ways or things you can look at, which honestly is the fun part of this job, because it's not only creative thinking, but it's forcing us to you to think outside the box to solve a problem, because problems like this have been solved, but it's not always the same problem, right? There's always some slight variation to whatever problem you're working with in software development. Like on this channel, I showed you what happens when you basically just send way too many requests at a single endpoint on a single machine. You get eventual out of resource errors. So we had to go back and modify. Then we switched to WebSockets, and then we added queues, and we did all these things because the data forced us in that direction. Now, you don't want to over-engineer it to begin with, but you want to let the data show you where I think you need to go. So all that to say is there's a lot that goes into API design. And it's not just about the response. It's everything that goes into the API and how much of decision making APIs really drive and why they're important. And I can't stress enough uh, when it comes to API design, you really need to make sure that you think about it up front as opposed to waiting till the end to define your interface. Thank you all for watching. I'll see you in the next one.